Hi friends, welcome to the Unit 5, Day 1, Example 5. We're going to start with Example 5. So now we're solving dependent inconsistent systems. These are ones that essentially are going to have one solution. So here I have 3x plus 4y equals 12. Solving a dependent and an inconsistent system. These are ones that don't have one solution. We're going to find out what happens. So here I've got 3x plus 4y equals 12 down here. Things are not written in standard form. I'm going to do that first. If I add 8y on both sides, then I have, in the first one, I have 3x plus 4y equals 12. In the second one, I'm going to have 6x plus 8y equals 24. So looking at these, you can see that if I multiply row 1 by -2, then I'm going to have the exact opposite of all of these others. So if I take row 1 multiplied by -2, then I have -6x minus 8y equals -24. So now if I combine these, everything cancels and I get 0 equals 0. Talking about that from above, that's going to be an a dependent system. So what happens here is that I have the solutions of all of these is just the same of the equations. What satisfies just one of the equations to be true. So this is why it's called this is why we called it infinitely many solutions, because they didn't just cross at one point. So this is infinitely many solutions. Then the bottom here, very similar. In fact, the only thing that's different, I have 3x plus 4y equals 12. This says 6x equals 12 minus 8y. So the thing that's different, that says 12, and the first one said 24. So my row 1 is the same. Row 2, however, so here you can see that it's not going to be the same. In fact, if I multiply the the top, row 1, row 1 by -2, I'm going to have -6x minus 8y equals -24. Then the second, row 2, is going to be 6x plus 8y equals 12. So if I combine these, I get 0 equals -12. That's not true. So this is an inconsistent system, or no solutions. So that's what's different. Essentially all the other stuff is the same, it's just those two caused it to be completely different. The rest of this involves some word problems, and these are actually word problems that we've done before just with one variable. Adding in a second variable can sometimes help, it depends. This one talks about Asia Clark, owner of Wild Moon Jewelry. So we're creating a piece of artwork. It's got to weigh 14 ounces and consists of 75% gold. So this is that combination. So instead of using a table, instead what I'm going to say is X is our 60% gold. And then Y is our 80% gold. So this is the amount. Remember, this is our ounces. So X is in ounces. So setting this up, my two different equations, if X is a number of ounces 60% and Y is the ounces of 40%, if I add those together, then I'm going to get my total, which is 14 ounces. And I know that X is my 60%, so I could do 0.6X and then 0.8Y. Now, a lot of students just want to stop here at the 0.75. The problem is that, remember, X is the weight, Y is the weight. So this also has to include the weight. So I also have to include that 14 here. So combining these together now, 0.75 times 14 is some number. I should know that. 75 times 14, 10.5. There we go. So that's going to be 10.5. Just put that there. So now I have my systems of two equations with two unknowns. I can use whatever techniques I want to solve. Elimination is probably going to be the easiest to use for this one. In a later chapter, we're going to see how we can use some other tools that we have to be able to solve. Actually, I think substitution. Yeah, I was saying elimination. I think substitution is going to be a little bit easier. So I'm going to solve this top one in terms of, let's solve it in terms of y. So I have y equals 14 minus x. So I just subtracted x on both sides. So I'm going to substitute now 14 minus x in for that y there. So that gives me 0.6x plus 0.8 times 14 minus x equals 10.5. So now I have 0.6x plus, now this part right here where I just said doing it in terms of the other, that's actually what we were doing in the beginning when we were first solving these problems using just one variable. Minus 0.8x equals 10.5. Looking good so far. 0.6x minus 0.8x is negative 0.2x. Now that's okay because I'm going to end up with subtracting this 11.2. And I'm going to end up with a negative on my other side as well. 11.2. So here we have negative 0.7 divided by negative 0.2, and I get 3.5. So x is 3.5, so that's the number of ounces. So x is 3.5 ounces for that. I know y has to then add up to be 14. So 3.5 plus y equals 14 minus 3.5 on both sides. I get y equals 11.5. 10.5. There we go. So y equals 10.5. So I have 3.5 ounces of 60% and 10.5 ounces of 80%. For the second one, talks about in home businesses, so people who work out of their home, talks about fixed cost and variable cost. Fixed cost is how much you know that they're going to be determined by just things that are outside of your control, rent, utilities. Variable costs are what you need to produce the item or the work that you're selling. So here we're talking about Camille, who's producing large decorative candles. So the cost of materials are $350 per candle, and rent utilities are $900 per month. If her candles sell for $950, how many candles must be sold to break even? Break even is when the amount that you're making is equal to the amount that you need to substantiate yourself in the business, which is in fact nothing. So if you're breaking even, you're coming out with $0 profit. This one is a little bit weird that they included it in this section because of how it's set up. I think it's just to introduce the idea of break even because I could not find a way to turn this into a two variable. I spent a lot of time trying to figure out a way, but you just have one variable in this, and that's how much how many candles you're selling. So if I think about my break even, my costs, so we're going to do the costs on one side. So it costs me $3.50 per candle that I buy. So X is the number of candles. Notice that I'm identifying my variables first before I'm going through and solving. I'm developing that idea first. So 3.5x. And then my other costs are going to be rent, that's $900. And then I'm offsetting, because I want it to break even, how much I sell each candle for. So I'm selling for $9.50. So if I subtract 3.5x on both sides, I get 900 equals 6x divided by 6, and I get x equals 150 candles. So I need to sell, Camille needs to sell 150 candles to break even. The last example is about wind and flying airplanes. This one's a little bit difficult to explain with an idea of two variables. For this particular problem, a lot of students struggle with it. So instead of doing it in the video where I can't ask and receive questions, I'm going to hold off and we're going to do this example problem in class. So have a wonderful day, and I will see you later.